Okay, so step one, let's swap the x and y values. So let's write it as x is equal to 1 over 3 minus 1. So I guess if we flip both sides, we get 1 on x is equal to 3y minus 1, add 1. 1 on x plus 1 is equal to 3y. Now we divide both sides by 3. 1 on 3x plus 1/3 is equal to y. So therefore we can write f inverse of x is equal to, we could try to tidy it up a little bit, but I think that's fine like that. So there's my inverse function, okay? Give the domain and range of the inverse, okay? Well, so the domain of f inverse is equal to the range of the original, and that function there has a range of r except for 0, because there's no translations up or down. And the range of this inverse function is equal to the domain of the original function, which is given by, let's think about that, which is given by from round bracket 1/3 to infinity. So now let's think about that. If we go back to the original graph, the original graph has an asymptote of 1/3. So it's actually translated, so that's the same as 1 over 3 x minus 1/3. It's translated 1 on 3 units to the right. So that's the original graph there. It actually has a range, doesn't it, from 0 to infinity. So let's put a big line through that one. And so the domain of this particular function is going to be from 0 to infinity. It's lucky we picked that one up. All right, what's happening down underneath? Again, find the rule of the inverse. No domain restrictions this time, so that's okay. So let's write y is equal to 2 over x minus 3 plus 4. So let's rearrange. 4, I get x minus 4 is equal to 2 over, should be a y there, shouldn't it? Y minus 3. So let's flip both sides. I'll get 1 over x minus 4 is equal to y minus 3 over 2. Multiply the 2 across. So I'm going to get y is equal to 2 over x minus 4 plus 3. Therefore, we'll write f inverse is equal to 2 over x minus 4. Let's just fix that up. Plus 3. Domain of the inverse function is the range of the original. So the domain of f inverse is equal to the range of f, which is equal to r except for positive 4. Righto. Explain whether or not f of g of x exists. So I need the range of the inside to be a subset of the domain of the outside. So the range of g is r, and the domain of f is equal to r except for 0, which is not going to be true, therefore does not exist. Okay, find a rule for g of f of x. So g of f of x means substitute f of x into g. So g of f is equal to 1 over 2x plus 1. Yep. Which if you like is just 1 over 2x plus 1. The domain of g of f, the domain of g of f is equal to the domain of f, which is equal to r except for 0. Alright, last one. That's a bit messy, isn't it? Alright, so the other thing, one thing to consider is g of x could be written as x plus 1 on x. I don't know if that's helping. I won't go that way just yet. So let's look at the left-hand side. Left-hand side, I get 4 times g of 2u, which is 1 plus 1 over 2u. Subtract g of minus u, which is 1 plus 1 over minus u. Okay, and that's equal to 4 times all of that, I should say. So I get 4 plus 4 over 2u minus 1 plus 1 over u. So that's equal to 4 minus 1, which is 3, plus 2 on u plus 1 on u, which is 3 plus 3 on u, which is 3 times 1 plus 1 on u, which is equal to 3 times g of u. Just put a little as required.